Now that we know how to compute surface area using integrals, let's look at an example. So here we have the curve y equals square root of x from 1 to 4. And let's revolve that around the x-axis and see what kind of surface area we generate. So first of all, I'm going to draw a carbon copy of that on the other side of the x-axis. Get a picture here of what we're looking at. So something like that. And remember our formula previously. Surface area, the integral from a to b, 2 pi rho ds. And this was the compact way of writing it. Remember, rho represented your radius of revolution. So when you're going around the x-axis, any point on here, when it goes around, will go around in a circle. And that radius is being determined by the curve, and that radius is y, right? So your rho, when you're going around the x-axis, is y. Your rho, if you were going around the y-axis, would be x, because x is your distance from the y-axis. So in this case, it's y, which is square root of x, being determined by the curve there. And then remember, ds required us to take the derivative of our function squared. So let's compute that first. So dy dx. Just doing power rule, right? X to the half comes down, 1/2 x to the negative half. And then square that. And we get that. So our integral we're taking our curve from 1 to 4, 2 pi rho, and as we said, rho was y, which is square root of x. And then remember, ds is 1 plus that, the derivative squared, so 1 over 4x dx. At this point, we've got 2 square roots. And remember, when you're multiplying square roots, you can combine those together. So let's do that to simplify this a little bit. And we would have 2 pi square root of x plus 1/4. And then at this point, it would just be a u substitution. And you could do, remember the shortcut, this is a linear u sub. In the shortcut, you just divide by the coefficient on x, which is quite nice because the coefficient on x is 1 in this case. So either way, I'll take the shortcut. So it would be 2 pi. This is to the half, so raise that to the 3/2. And then divide by 3/2, or multiply by 2/3. And we're taking all of that from 1 to 4. And this stuff combines up. The 2 pi and the 2/3 combine up as a constant. We could take that out of the integral. And then it's just a matter of evaluating this expression here at 4 and at 1. So we have 4 pi over 3. 4 into there would be 4 1/4, or 17/4 to the 3/2, minus 1 1/4, or 5/4 to the 3/2. And there would be our surface area. We could neaten that up a little bit if we wanted to. 17 to the 3/2 is irrational. There's nothing you could do there. But 4 to the 3/2 is 8. So you could take an 8th out. But other than that, we're essentially done at that point. Typically, you're going to have to do a little manipulation. Remember, integrals involving roots with functions inside the root can typically be tricky. You'll either be doing some sort of u substitution, probably doing some combining up of stuff outside with stuff inside. So you'll be using some of your tools of algebra or u substitution on a lot of these problems.